Hello everyone, my name is Shubham, back with a new video, and in this video we are going to start our new module, which is operating system basics. And we have 5 chapters in this room, and today we are going to do the first chapter, which is operating systems introduction. So before any further ado, let's get into this chapter. Let me join this room by clicking on the join room button, and you can see it's not showing the premium room button here. So if you want to follow along with me, you can do that. And make sure to keep good notes while I'm going through this chapter. And the first task of this chapter is the introduction. And let me amp up the text so that you can see it clearly. You turn on your phone or laptop every day and everything just works. App launch, file open, music plays, and the whole system feels seamless. But what actually makes all this possible? In the computer fundamentals module, and let me tell you, we have done that module. So if you want to watch that module, you have to go through the series that I am doing right now, where you can find this computer fundamental module. You explored the physical components of a computer and the different types of computing devices. Now it's time to uncover the invisible layer that ties it all together, the operating system, or OS for short. So we have scenario. Your friend just upgraded their primary computer and, knowing you are getting into tech, has generously gifted you their old machine. It's been sitting untouched for a while, and he can't remember much about it, only that it used to run well. Before you can decide whether to upgrade it, wipe it, sell it, or turn it on your next project, you need to figure out precisely what you are dealing with. Now, what are the learning objectives? Understand what an operating system is and the role it plays. Explain the core duties of an operating system. Identify common OS types and their physical use cases. Practice interacting with an operating system to gather system information. So, what are the prerequisites for this room? Before you begin this room, it is recommended that you complete the computer fundamental module. We have done that. Why it's showing here coming soon, I don't know. Of the pre-security path, and you know that we are doing our pre-security path from the day one of this series. This room builds on core ideas introduced earlier, especially your understanding of computer hardware, device types, and how modern system boot and operate. Inside a computer system, computer types, we have done these two rooms too. So if you want to see those rooms, you can follow this series. Let me answer this question. Yes, we understand. And let me check this answer. Now let's go to our task 2, which is the invisible manager. An operating system, for short OS, is the core software that coordinates everything happening on a computer. It sits between the user applications and the system's physical hardware, acting as the invisible manager that keeps the entire machine running as one unified system. So this is the diagram: user, application, operating system, and then hardware. A helpful analogy is to think of a computer as a busy airport with all the components functioning together. Your hardware, CPU, RAM, storage, connected devices, the runways, airplanes, fuel systems, radar, and other physical infrastructure. Your applications like web browser, game launcher, the various airlines, and their passengers, all trying to take off, land, and request services. Your operating system, that will be Windows, Linux, and Mac OS, whatever you are using, it depends on you. The entire air traffic control system, directing all the activity. It schedules resources, manages traffic, resolves conflicts, and ensures safety. So we are comparing here our computer systems operating system with an airplane's runaway or airport. So I hope that relates somehow. We need an operating system because it provides this all important job of coordination and structuring that makes modern computing possible. Without an OS, each application would need direct control over the CPU, memory, files, devices, and security. This would quickly cause conflicts, and the OS handles this by acting as the central organizer. In the Computer Fundamentals module, you learned about various components and their duties. Now we will see how the operating system manages and allocates these resources when you use your PC. System privilege layers. Inside a modern computer, different parts of the system operates at various permission levels. Some components can communicate directly with the hardware, while regular applications run as a safer, restricted environment. This separation is intentional and helps prevent conflicts and security issues. Now, kernel space, the privileged locked down core of the OS. This is where the kernel, the part of the operating system that directly manages hardware and system resources, runs. It has unrestricted access to the CPU, memory storage, and all hardware components. User space, where all standard applications run. Applications in the user space are deliberately prevented from accessing hardware directly. Whenever they need to open or save a file, play a sound, or connect to Wi Fi, they must make a system call and request that the kernel act on their behalf. Building on our airport analogy, let's zoom in on the concept of privilege separation. The kernel space is the control tower, a strictly secured area where only trusted air traffic controls the kernel work. They alone can directly control the runway, radar, and other hardware. Applications in the user space are like airlines and passengers on the ground. They can't enter the tower or touch the equipments. Instead, they radio requests, like system calls in a computer system, to the tower, which handles them safely. This separation keeps the OS reliable. One faulty app cannot crash the whole system, just as no airlines can operate safely without the tower's control. Operating system duties. Now that you know what an operating system is, how system privilege is separated, let's look at what it actually does behind the scenes. Every operating system is responsible for a few core duties that allows your computer to run safely, efficiently, and predictably. OS responsibilities. So we have some responsibilities that a OS has: process management, memory management, file system management, user management, and device management. What the OS does and their examples. So let's go with the first one, which is process management. Creates schedules, prioritizes, and terminates running programs. The OS decides how much CPU time each process gets, making multitasking feel seamless. And what is this example? Is opening multiple apps like a browser, music player, and social media without your computer freezing. So that is the process management. All the process is managed by the CPU so that it won't hang your PC. Now, second is memory management. Allocates RAM to processes, protects the app's memory from other processes, and reclaims memory when apps are closed. When RAM runs low, the OS uses virtual memory to keep your system stable. Opening multiple apps at once, the OS allocates RAM to each one and keeps them isolated so they don't interfere or crash each other. Now, the file system management organizes files into directories, handles. I think I have to put my charger. Just wait. So, where we were before that charger ad. So, file system management organizes file into directories, handle naming, paths, permissions, metadata, name, size, type, and timestamps. creating a new folder, saving a photo, or setting a file to read only. Now, the next one is user management. Handles multiple user accounts, authentication, and permissions to determine who can access what, logging in with your password, and keeping all files inaccessible to other user accounts. And the last one is device management. Loads drivers and provides a universal interface, hardware abstraction layer. So apps can run, print this, or play this sound. Plugging in a new mouse, printer, or external hard drive and having it work immediately. So this is what we call device management. Now let's go further. Operating system security. It is important to understand that every OS also acts as a security foundation. Before any antivirus, firewall, or security tool is introduced, the OS is already enforcing protections in the background, some of which we covered above. At a basic level, your operating system handles. And what it handles, these four things: authentication, permissions, isolation, system protection. The first is authentication. Verifies who you uh, verifies who you are through login passwords and biometrics. Permissions controls exactly what each user and app is allowed to read, write, or execute. Isolation keeps every process in its own protected box. Kernel or slash user space separation. And the last one is system protection. Safeguards critical system files and settings from unauthorized changes. Getting hands on. Now we have to do something with that lab machine. So now that you have a solid understanding of what an operating system is and its main duties, let's get hands on with your new computer. Click on the Start Lab machine. Let me click it because it will take some time. Button below to fire up a new computer. This machine will open in a split view, at which time you will gain access to computer's desktop. If split view is not opening, press the split view, blah blah blah. We know that. Now, remember your friend said he doesn't know much about the PC he gave you. So let's dive in and try to gain some initial information about what you are working with. On the desktop of the machine, there is a shortcut named about this computer that opens a computer's system monitor. Go ahead and open it now as you will need it for some of questions in the tasks. So these are some of the questions that we have to answer after clicking on that about this computer shortcut. So our machine is up now and this is the button we are supposed to click and it will show some of the details of this computer. Now let's answer some of the questions. Which OS space has unrestricted access to your computer's hardware? That will be kernel space. Which OS responsibility manages user accounts, authentication, and permissions? So we have read that. Let me again find that. Account user management. Yes, user management. Now, the third question is, after opening the About this computer shortcut, you are greeted with an overview of the system's specifications. What version of Ubuntu Mate is your computer running? So let's quickly grab that from here. And our version is this 24040 and Mate. That will be the Mate version, not the Ubuntu version. So this is the answer. Now, the last question is check out the hardware section of the system tab. How much memory is allocated to your machine? Let's go there. Resources, systems, file systems. That is 9.3. How much memory is allocated to your system? That is the hardware, and the memory is this 1.9 gigs. Let me paste it here, and it's correct. Now let's go to our task 3, which is OS interaction and landscape. The first thing is OS interfaces. Now that you have a solid understanding of operating system and its various responsibilities, let's look at how we interact with the OS. Interaction with the OS can be divided into two parts. The graphical user interface, that is also called GUI, and the command line interface, that is CLI. Graphical user interface. So whatever you are seeing is a graphical user interface, and if you want to control your computer using a command prompt or a terminal, that will be command line interface. Now the first is graphical user interface. The GUI is what you are most likely used to interacting with. In Windows specifically, it provides a graphical representation of all the information you want to access on your computer. Think of folder icons, windows for your applications, and menus for settings. We can imagine the analogy of using a navigation application. You tap an icon of the place you want to visit, and the app generates directions for you, eliminating the need for typing. What is command line interface? The CLI is where you enter specific text based commands to retrieve or manipulate information. Instead of clicking on icons, you tell the computer exactly what you want using words and syntax that the system understands. This gives you far more precision, control, and speed, especially for advanced tasks, but it requires familiarity with the commands. And these commands we are going to learn in our next video when we are going to do that chapter, which is command line interface basics or Windows basics. Basically, we are going to learn the commands and how to use these commands to navigate through the Windows systems or Linux systems. Back to the maps analogy, using the CLI is like entering the exact GPS coordinates of your destination. It's direct and extremely accurate, but only if you know the correct information to type. Later in this module, you will explore the CLI on both Linux and Windows. That's what I was trying to say. To learn how to navigate files, inspect system information, and interact with your OS beyond the GUI. In the screenshot below, you can see that the GUI and CLI are both used to retrieve the same information, in this case, to display the content of the Ubuntu user's home directory. The GUI requires a few clicks for folder navigation, whereas the CLI requires a command to list the directory contents. So here you can see that we are navigating uh, through GUI, which is the visual representation of folders and icons where we can click and go inside and out of a folder or a directory. But in CLI, you can see that we just have to type ls ubuntu and all the files inside this Ubuntu directory is shown here. The operating system landscape. Nice. We are gaining a much clearer picture of the OS and its responsibilities and how we can interact with it to manage our computer. Now it's time to look at the bigger picture. Not all operating systems are the same. Different devices and jobs demand different designs, ranging from your phone to a web server in a data center. Below are the 5 major categories you will run into in the real world. Let's see what are those categories. So the first field is operating system type, and these are some of the types of operating systems. So the first one is desktop, personal computers, daily work, gaming, content creation. That's what I am doing right now, content creation. Key characteristics: rich graphic interface, runs many apps at once, user focused. Now, the second one is server, web hosting, databases, cloud services, and back end. Headless, no GUI, maximum uptime, multiple user, remote access. Mobile, smartphones, and tablets. Touch based UI, power efficient, always connected, app sandboxing. Now, the fourth one is embedded. Appliances, cars, IoT devices, smart TVs, routers. Tiny footprint, runs on limited hardware. Now, the last one is virtual or cloud. Lab machines, that this is what is a lab machine that you are seeing on your screen. Containers, cloud instances. Lightweight, scalable, rapid deployment. Now, let's go further. Real world operating systems. Now that you have seen the different types of operating systems and what they are designed for, let's look at the major families of operating system you will encounter in the real world. Each family fills one or more of the operating types we just explored. To keep things organized, we will highlight the common versions or distributions you will see in each and follow the same categories as above: desktop, server, mobile, embedded, and virtual or cloud. Desktop. So in the desktops we have Windows, Mac OS, Linux. So we can find these three operating systems in our desktops. And let's see what we have in servers. So we can run server on Windows, Linux, and Unix. So the new thing is Unix. Large enterprises, finance, telecom, government. IBM, AIX, Oracle, Solaris. Now the next one is mobile. So you know that we have two things in a mobile, that is Android and iOS, but you can also jailbreak or root your system to add like Kali machine or Kali Net Hunter in your machine, in your phone, so that you can run Kali from your phone directly. Now the embedded and IoT devices, we can have Linux and real-time operating systems. So what are the examples of embedded operating systems? That are OpenWRT, Ubuntu Core, Yocto project. And real-time operating system is FreeRTOS, VxWorks, and QNX. Designed for apps where tasks need guaranteed response times, so like aircraft control. So if you want a very fast and guaranteed response, you can use the real-time operating system, and these are those. Now the next one is virtual and cloud. Virtual VM, massive data centers that hosts websites, apps, and streaming services like Ubuntu, Amazon Linux, Rocky Linux. Container optimized. So these are the container optimized lightweight alternatives to VMs that package just the app and its dependencies. A applying Linux, Bottler Rocket AWS, or Flatcar Linux. Why so many operating systems? Different devices and environments require different capabilities from an operating system. A laptop must be user friendly and support multitasking. Servers require stability, security, and must be able to run continuously without interruption. Mobile devices need power efficiency and hardware integration to extend battery life. Embedded systems use lightweight operating systems designed for its purpose. The companies and communities that develop these operating systems also have their own goals. Some focus on ease of use, performance, security, openness, or customization because each environment values different capabilities. No single OS is the perfect fit for every situation. Continuing your investigation. From the previous task, you learned that new computer is running the Ubuntu distribution of Linux. You were also able to determine the version and release. Let's continue the investigation and gather further information about the system. You will continue to use the About the Computer shortcut, then jump into the Home directory, which can be found on your computer's desktop. So these are some of the questions that we have to answer using this machine. So the first one is open the file system tab in the system monitor. What type is listed for the developed device? File system and system monitor. So we have to go to file system and system monitor. That is the ext4. Now the next question is, after opening the home directory on the desktop, how many user directories exist? Now let's go to the user home directory. So let me show you how we can use the CLI to find this information. Let me close it and open the terminal, and we can let me first see what is the current working directory, which is the command to show the current working directory is pwd. It's also called print working directory. Now if we press ls, this will show the files that are inside that current directory. And what we have to answer is after opening the home directory. So we are in the home directory and we have 1 2 3 4 5 6 7 8 9. We have 9 directories here. And I messed up something. Cd slash, if you want to change the directory, you can press cd slash home, then press enter. Let me ls here. So we have 3. I'm clearly taking you to the wrong direction. Beware. Navigate to Alex's home directory and explore the documents folder. What is the flag value contained in node.txt? So now we have to go to Alex. So here you can see we have Alex here. Now let me tell you how to navigate through GUI, that is graphical user interface. So we are in home directory and we are in Alex. I think we have to go to the documents, not desktop. You see, that's what I'm missing. So let's go to the downloads, and here you can see nothing here. We are in downloads. We have to go to the documents. So here is the notes.txt. Let me show you how you can navigate to that note.txt using CLI. Now ls, and let me see my present working directory. Let me go to home, and after that ls, and then documents, and let me press enter. If I do ls, I can see the content of that directory. And if you want to see the content of that text file, you can type cat and the name of the file, that is note.txt. And here we can see our flag. So that's how you can use GUI and CLI to navigate through the directories. And that's the correct answer. And let me take you to our last task, which is conclusion. Well done, you have reached the end of operating system introduction. In this room, you learned what an operating system really does behind the scenes and explored key concepts, including privileges, user management, memory handling, and processes. In the practical exercise, you investigated a mystery computer gifted to you by a friend. You used the operating system to take a peek into the hardware and file system it helps manage. Key terminologies. So let's recap the core items you have learned. The definitions will help solidify your understanding before moving on to further learning. So these are some of the terminologies that you have to keep in your mind, so that if in the next chapters you see anything like that, you know that this is the operating system, or this is the kernel space, or this is the user space, everything. The operating system, the core software that manages hardware applications and all system resources. Kernel space, the OS is highly privileged area with direct hardware access and the home of the kernel, which directly manages hardware and system resources. User space, the area where regular users run with limited permissions for safety and system stability. Graphical user interface, the visual part of the operating system, windows, icons, and menus that lets you interact through clicking and tapping. CLI, that is command line interface, a text-based interface where you type commands that I have showed you just now to control the system with precision and speed. Further learning. In the following room of the operating system module, you will dive deeper into the Windows and Linux operating system. That will be interesting. Learning how to navigate each system using both the GUI and CLI. You will gain further hands-on experience performing real tasks, gathering system information, and interacting with the OS. Windows Basic will be our next room. After that, we will go to the Linux CLI basics, then Windows CLI basics. Now let me check this button, and we have successfully completed our first chapter of the module, which is operating systems. You can share your achievement using these links, but I don't want to do that. You are free to do that. And let me tell you what we are going to do next, which is Windows Basics. And after that, Linux CLI Basics, which is very important. And after that, Windows Basic, which is also very important because when you are hacking a Windows machine, you have to navigate through Windows CLI commands. So that's for our next videos. If you like this video, please do like and subscribe. That how you can buy me a coffee. So I will meet you in our next video, that is Windows Basics. So bye bye and stay safe.